Yesterday we went over how to form a quadratic equation when we were given a point and the vertex. Today we're going to be given a point and the X-intercepts. So we're going to be using intercept form. So our intercepts are going to be our P and our Q. We're just going to plug those in for our P and Q. And we plug in our X and Y's. And then we just need to find A. So we're doing the same thing as yesterday, but instead of plugging it into vertex form, we're using intercept form. So we left off on example 2. So we need to write an equation using a point and X-intercepts. This says a meteorologist creates a parabola to predict the temperature tomorrow, where X is the number of hours after midnight and Y is the temperature in degrees Celsius. We need to write a function f that models the temperature over time and decide what is the coldest temperature. So first thing we need to do is write a function. So we need to come up with our equation. Looking at our picture here, it gives us a point, X and Y, and then it gives us our two intercepts. So this is going to be our P and this is our Q. So now we just need to plug everything into our equation. So our intercept equation is Y is equal to A times X minus P times X minus Q. We plug in our Y, which is 9.6. Our A is what we're trying to solve for, so we don't have anything to plug in there. We plug in our X, which is 0, minus P, which is one of our intercepts at 4, and then 0 again, minus 24. So it doesn't matter which one's your P and which one's your Q, because you'll end up getting the same thing. So now we simplify and solve our equation. We have 9.6 is equal to A times negative 4 times negative 24. Negative 4 times negative 24 is 96. So 96 times A is equal to 9.6. We divide both sides of our equation by 96. And we get 0.1 is equal to A. What do we do once we find our A? We plug it in. So we have Y is equal to 0.1 times X minus our P, which is 4, and X minus our Q, which is 24. So here, it's important that we plug in the A, and we plug in our P, and plug in our Q. So yesterday, we plugged in our A, H, and K. Today, we're plugging in A, P, and Q. Okay, that's the first part of the question. Write a function f that models the temperature over time. So that's our function here. The next part says, what is the coldest temperature? Looking at our graph here, what do you think the coldest temperature is? Negative 10. So remember, we're looking at the temperature, and the coldest it gets is negative 10. This is our minimum on our graph. If we weren't able to see that this is negative 10, we could always find the minimum by finding our vertex. So how do we find our vertex when we have our equation in intercept form? What's that? How do we find the first value of our vertex? We have our P and our Q. So what do we do with our P and our Q? Well, those are two intercepts, but we're looking for our vertex. We're looking for this point here. So what do we need to do to find our vertex? Remember how we take the average of our intercepts? So 4 plus 24 and divide by 2. Anybody remember that? It was on your quiz that you just took. So 4 plus 24 is 28 over 2. This would be 14. So our first value in our vertex is 14. How do we find the y value in our vertex? Plug it in. So we plug 14 in for our x's. So we have y is equal to 0.1 times 14 minus 4 times 14 minus 24. So we have y is equal to 0.1 times 10 times negative 10. So y is equal to negative 10. So our y value in our vertex is negative 10. So our minimum is what? What is our min point on the graph? Negative 10. So our coldest temperature is negative 10. And to be more precise, we would put negative 10 degrees Celsius, just so we see that we're talking about the temperature. So our coldest temperature is negative 10 degrees Celsius. So that answers part A. Now we need to look at part B. So here we're doing something new. It's asking us for the average rate of change in temperature over the interval in which the temperature is decreasing and increasing, and then we need to compare the average rate of change. So first thing we need to do is find the average rate of change when it is decreasing. So our average rate of change, if we look over here to the left, is this formula. This is our change in y's over the change in x's. So f of x is just a fancy way of saying y, so we could rewrite this as y2 minus y1 over x2 minus x1. So we take our change in y's and put it over our change in x's. So this is our rate of change. Now we need 2 points in order to plug in and find our average rate of change. So we're looking about what is our average rate of change in temperature over the interval in which the temperature is decreasing. So the interval in which our temperature is decreasing is from this point here, 0, 9.6, and our vertex, which we said was 14, negative 10. So we need to find our rate of change between these 2 points. So our 2 points for our rate of change are going to be 0, 9.6, and 14, negative 10. We need to find the average rate of change between these 2 points.
Why those two?
Because it asks us over the interval in which the temperature is decreasing. The temperature decreases from here to here. So that's why we use these 2 points. So we have our first point on top. 0 is going to be our x1. 9.6 is going to be our y1. Our second point is on the bottom, so we have our x2 and our y2. And now we just plug all of these in into our rate of change formula. So we have y2 minus y1 over x2 minus x1. And then we just solve. So negative 10 minus 9.6 is negative 19.6 over 14. And this simplifies to negative 1.4. So our average rate of change is negative 1.4. That's when it's decreasing. Now we need to find the average rate of change when it is increasing. So let's look at our interval at which it's increasing. Our graph is going up, starting at the vertex and going to this point. This is the interval in which it is increasing. So our 2 points we're going to use here is our vertex, 14, negative 10, and our point at the end, which is 24, 0. So our 2 points are 14, negative 10, and 24, 0. Can you guys see that on the blue, or should I change the color? I'll change it. So our first point is our x1 and our y1. Second point is x2, y2. Then we just do the same thing we did in the last one. We plug it in. So we have y2 minus y1, 0 minus negative 10 over x2 minus x1. What is 0 minus negative 10? 10. And then 24 minus 14 is also 10. So our average rate of change is 1. Okay, so that is everything for example 2. Any questions? If our y-intercept changed, it would now be, they said 4.8, so it would now be here, so then our graph would go here. If our y changed, that would change the y here, which would then change our a, which would change our whole equation. We would have a new equation, and it would pretty much just change everything. It would give us a new minimum here. It would change our max and min, so everything would change if our y-intercept changed. All right, on the next page, we have another one of those what ifs. So what if the y-intercept is 4.8? How does this change your answer in parts A and B? If our y-intercept changed, so looking back at the slide before, so we could do this whole problem again, but we're going to skip it for now because we just did the same exact thing in the one before, but it would give us a new a new equation, and a new y in our vertex. All right, number 4 is much simpler than the first example. So we need to write an equation of the parabola that passes through the point 2, 5, and has the x-intercepts -2 and 4. So what is our x, what's our y, what's our p, and what's our q? So starting with x, what number is our x? 2. Perfect. What's our y?
5.
What's our p?
-2.
Awesome. And what's our q?
4.
Perfect. Again, it doesn't matter which one we say is our p and which one's our q, because we'll end up getting the same thing. So we plug it in now. We're plugging it into our intercept form equation, so we have y is equal to a times x minus p times x minus q. Our y is 5. Our x is 2. Our p is -2, so what happens to our equation when we have 2 and a -2? A 2 minus a -2.
Keep, change.
It becomes a plus sign. Yeah, so I guess keep, change. So this would be 2 minus a -2, which this would become a big plus sign. And then we plug in 4, so this is 2 minus 4. And now we solve. So 5 is equal to a times 4 times -2. 4 times -2 is -8a. And then we divide both sides by -8. So a is equal to 5 over -8, or -5 over 8. Now what are we going to plug into our equation?
The a, the x, and the y.
We plug in the a, what else?
The P and Q.
The p and q. We plug in our a, our p, and our q. So we have y is equal to -5 over 8 times x minus p, which is -2, so it becomes a plus, and then x minus 4. So this is our equation of our parabola. Yes.